Welcome back to Arithmetic with Ron. Today we're going to look at long division where the answers are decimals, and we'll find out why it's called long division. Go ahead and hit subscribe and enjoy the video. Let's begin today's work with the question, what is 8 divided by 5? We're going to write that as a long division problem, 8 and divided by 5. If this does not come out as a whole number, we're going to see what kind of decimals it produces. So when we do that, what we're going to do is add a decimal and a placeholder 0. This placeholder 0 does not change the value of this number. It's still 8, but it's going to give us extra digits to work with if we have a decimal. When you do this, it's very important to treat the decimal just like a place value, and we want to right away put it up in the quotient, right above where it is in the dividend. That way our decimal point won't get lost and end up giving us a wrong answer. Now let's ask ourselves the question, how many times does 5 fit into 8? It fits in once. 5 times 1 is 5. We subtract and we have 3 left over, and now we can bring down the next digit. We didn't have a digit before. We added a placeholder 0 so that we had something to move down. And again, once you put the decimal in the right place, you can ignore it because you've already taken care of the decimal in the answer and you can just read the digits. All right? How many times does 5 go into 30? Well, it goes in 6 times. 5 times 6 just happens to be 30. So when I subtract, I have nothing left over, which means that I'm done, and my final answer is 1.6. 8 divided by 5 is 1.6 as a decimal, and if you read that backwards, 1.6 times 5 is equal to 8. Let's take a look at an example that's a little bit more difficult, but uses the same principles. 33 divided by 8. Okay, we're going to ask ourselves, how many times does 8 go into 3? Well, it doesn't. So we're going to put a 0, we're going to multiply, we're going to subtract, and bring down the next digit. And 8 goes into 33 4 times. Okay, 8 times 4 is 32. Now look what happened. We have 1 left over, and we have no more digits. Okay, since we're looking for a decimal in our answer, we're going to put a decimal and a placeholder 0. And the next thing we're going to do is move that decimal straight up so that it's in the correct position in our answer. Now I have a 0, and I can move him down, and I have the number 10. How many times does 8 fit into 10? It fits in once. 8 times 1 is 8, and when I subtract, I get 2 left over. And now I can add another placeholder 0. I can bring it down, and I get 8 into 20, and that goes in 2 times. 8 times 2 is 16. I know this is getting a little tough to read here, so I'm going to move this up here. I had 20. I'm going to subtract 16 because 8 times 2 is 16. I'm left with 4. And the final placeholder 0 right here, that is a terrible 0. Let's go ahead and fix that. The final placeholder 0, if I were to drop that down, it would land right here next to the 4, and it would make 40. And 8 goes into 40 5 times. 8 times 5 is 40. So now when I subtract, I have nothing left over, which means I'm done. And the final answer, 33 divided by 8, is 4.125. How about 22 divided by 7? Let's ask ourselves, how many times can 7 fit into 2? Well, it doesn't. So we multiply and we subtract and bring down the next number. And now we have 7 into 22, and that happens to fit 3 times. 7 times 3 is 21. And now when we subtract, look that we have 1 left over, but we are out of digits. So I'm going to put in a decimal point and a placeholder 0, and then I'm going to move that decimal straight up so that he's in the right place in our quotient. Now I can bring down this 0 like this, and ask myself, how many times does 7 fit into 10? Well, it fits one time, and when I multiply, I get 7, subtract, and I get 3. Now I can add another placeholder 0, so that when I bring this down, I now have 30. 7 fits into 30 4 times. 7 times 4 is 28. When I subtract, I get 2. Add another placeholder 0 and bring it down. 7 fits into 20 2 times. 7 times 2 is 14. I get a 6. Now look what's happening here. I've got an awful lot of zeros that I'm adding. 7 goes into 60 8 times. 8 times 7 is 56. And what I'm going to do is stop right here, because look what's happened. We have not been able to get to 0 after we subtract. We could keep doing this process all day long and it would never stop. So today we saw what happens when we do long division with decimals and why it's called long division, because it takes so long. Anyway, thanks for watching. Go ahead and let me know if you have any questions or comments, and we'll see you next time.